In this video, I'm gonna explain two key points in the RAM Ping Pang code. These are design code and simulation code. First, here we use a condition operation. The judgment condition is when write A enable delay is 0, we read A data, else we read B data. The problem is that FPGA writes the data at the first time. If we don't use read enable, write A enable is 1 at this moment, then FPGA starts reading the data. However, run B is empty at this moment. Thus, we need to add a variable read enable to judge the correct reading time. When the read enable is 0, we can set read data to 511 and this number will not be used to write into RAM. We can use 511 to judge if read data has valid data. Second, let's see the reason why we use write A enable delay. Here is the oscillogram that we directly use write A enable to judge to read A data or read B data. The first switching is controlled by write A enable and read enable, so it will be fine. Let's see the next write A enable switching. We can find that the first data will last 2 clock periods. The reason is we are using a non-blocking assignment to assign read data. Read data will immediately change as write A enable changes. Here, write A enable value is 1 rather than 0 due to the non-blocking assignment. So, read data will return the value of read B data address 0, namely 0. And the next clock period, it will still return the value of read A data address 0, namely 0. We found that read A data address 1023 value cannot be returned due to write A enable being early set to 1. Now we add a register to add a period delay. We found the value of read A data address 1023 can be successfully returned and the problem has been resolved. That's all for today's video.